Given that cos A is minus 5/13 and that A is a reflex angle, we want to find the exact value of tan 2A. We know that the cosine is negative and that it's a reflex angle. Reflex means that the angle is more than 180 degrees. If we look at our cast diagram, that tells us that the angle is in this region more than 180. But the cosine is positive in this quadrant, so the angle A must be in the T quadrant. In the T quadrant, the cosine is negative, as we can see above, and it is also a reflex angle more than 180. So our angle is in the T quadrant. Now let's consider this triangle, where the hypotenuse is the line showing our angle in the cast diagram above. If this side is 5 and this one 13, Pythagoras' theorem tells us that this one is 12. You should know that 5, 12, 13 is a right-angled triangle, but if you didn't, you could have used Pythagoras' theorem. Our angle A above will be associated with the acute angle alpha. So we know that our angle A is associated with the acute angle alpha. And we can see in the triangle that the opposite is 12 and the adjacent 5. Since we're in the T quadrant, the tangent is positive, so the tan of A is the same as the tangent of alpha, which is the opposite divided by the adjacent. We now want tan 2A, and we have the double angle formula. Tan 2A is identical to 2 tan A over 1 minus tan squared A. For this particular value, tan 2A is equal, and notice this is an equals now because we're dealing with a specific value. It's going to be 2 times 12 over 5 divided by 1 minus 12 over 5 squared. This gives us 24 over 5 divided by 1 minus 144 over 25. And this is 24 over 5 divided by 25 over 25, take away 144 over 25, which is minus 119 over 25. So we have 24 over 5 divided by 119 over 25 means we turn the second fraction upside down and multiply. 5 goes into 25 5 times. 5 times 24 is 120, so we have minus 120 over 119.